Okay, in all the examples we've looked at so far for compound interest and for reducing balance loans, we've looked at compounding periods which are annual. In this example, we're going to look at when the compounding period, so the period at which they calculate the interest on the loan, is not every year, but instead it's monthly, or it's quarterly, or it could be even weekly. We're going to do three different periods here. So in reality, most banks don't calculate interest once a year. They'll actually calculate on a mortgage, they'll calculate it once a month, depending on what you've paid. So that's what we're going to kind of work on for this example. Jared has borrowed $2,500 from a bank with a 6% per annum interest rate. Now, in actual fact, 6% per annum is not always true. Now, if it's a yearly compounding period, then that is true. But in reality, if it's monthly, then the rate is technically slightly higher than that. So we're going to show why that is in a minute. So this example wants us to write down a recurrence relation and a formula to model the value of, not Brian, Jared's loan. So V0 is 2,500. Vn plus 1 equals Vn plus, times, and then this is the multiplier bracket now, plus or minus r over 100. Now in this case r is 6, plus or minus is a plus because it's compound interest, it's going up, and so that ends up being 6 over 100, which is 0.06. Add that together, you get 1.06. Okay, so that's the decimal version of the multiplier. So that's what we call the recurrence relation. We also want the formula as well. So that's recurrence relation, now we want the formula. So the formula is for any value of Vn. So Vn can be found by getting the starting value, which is 2,500, and timesing it by 1.06, the multiplier, to the power of n. So we're being asked later on about the value of Jared's loan after 1 year, but I'm going to come back to that part. If it's quarterly, what that means is the loan has been broken up so that it's calculated every 3 months, or 4 times per year. And so because of that, instead of 6% per annum, okay, that's no longer done. It's actually 6 over 4, which is 1.5% per quarter. Okay, so the way we can show this in the recurrence relation is with a different multiplier. So 2,500, and this time Vn plus 1 equals Vn times 1 plus r over 4 times 100. Now, by putting it over 4, it divides it by 4. So once again, I put 6 in there, and this will have 6 divided by 4. And then also, whatever that number is, divide by 100. So that gives us 1.5 over 100, which is therefore 0.015. Okay, and that adds to 1 to make 1.015. So the multiplier this time is 1.015. You can do that straight from the calculator by doing this. 1 plus 6 over 4 times 100. Or you can just write 400. 1.015. Now the formula for Vn, so to find any value of Vn, is where you have 2,500 and you times by the multiplier to the power of n. N this time will have to be 4 times as large because it's doing it 4 times as often if it's quarterly. Lastly, we're going to do monthly, so this is 12 times per year. So instead of it being 6%, divide that by 12, you get 0.5% per month. Okay, instead of 6%. So they do it much more frequently, but with a much smaller percentage. So this time V0 is going to be 2,500. Vn plus 1 equals Vn times 1.005. Okay, because if you work out 1 plus 6 over 12. So that's going up 0.5% every time now. So if we want to find out Vn now, you're going to get 2,500 times 1.005 to the power of n. Okay, now, if we want to calculate the interest in 1 year for each of the 3 examples, go back to the beginning. For this one, in 1 year, n equals 1. So therefore, we can work out the new value, V1, 2,500 times 1.06. No power. 2,500 times 1.06. 2,650. So the interest on that, if we take it away from the original, is 1. Moving on to the next one. This time, in 1 year, you're going to have 4 compounding periods. So V4 is equal to 2,500 times 1.015 to the power of 4. And this should give us a slightly different number. Slightly higher than before, see? $3 more. I know it's not much, but with a larger loan that can make a big difference. So we round that to 2 decimal place, so it's 41. It's 2653. 53.41. And once again we have to work out the interest. So 2653.41 take 2,500 gives us 153.41. We should write down the interest on the side here. So this was $150 interest. That's our final answer. Make it nice and clear. This one here is 151.41 interest. The last example now. Let's just draw a line there. Make it... Okay, the last example we're going to get monthly for a year. So that's going to compound 12 times with a very small percentage. So V12 is 2,500 times 1.005 to the power of 12. And as you would predict, this is going to go slightly higher again. So we've made $1 extra. So 2654.19. 2654.19. So that tiny amount extra was because it was compounding more frequently. Okay, so as you can see, the one with the most interest is the one with the highest compounding period. And if you think about it, that makes sense because the bank isn't waiting a year before it calculates your interest. It's giving you your interest more regularly. So it sees that you've saved up more money, so they're going to calculate your interest again and give you a little bit now and another little bit next month and another little bit next month. And that regularity means that you're getting topped up more quickly. So your interest is getting calculated more frequently. So if you were to look at it on a graph, you would have a curve like this, or a curve like this, or a curve like this. For the same reason, if you pay off your mortgage more frequently, and you can pay it off weekly, some people pay it off weekly, that's if you do it monthly, that's if you do it fortnightly, and that's if you do it weekly. So it just means that you reduce the balance of your loan quicker. So compounding periods is really, really important in personal finance.